Orange has the popular edge. All right, let's go through these. So in duck-type languages, can LSP violations occur even in the absence of inheritance? Well, if you think about LSP as being a statement about substitutability of one thing for another and thereby breaking a contract, here's a counterexample, right? Here's a sort of pathological, trivial, but genuine LSP violation in a, here's a genuine, even if trivial, LSP violation in a class that's tried to include the comparable module, which makes the assumption when you include it, right? What's the contract of comparable? The contract is that you implement this, and by the way, that you implement it in a way that satisfies the triangle inequality, right? So this is a sort of trivial example, but you can imagine another example would be if I implement this in a way that doesn't obey the triangle inequality, then some of the things provided by comparable, like sorting, just won't work anymore. So here's a case where there's no inheritance in the traditional sense, but there is the contract, a concept of a contract, and I'm breaking the contract by having a behavior for this operator that's stupid and doesn't obey what the contract is. So that says that in duck-type languages, it is possible to have LSP violations even in the absence of inheritance. Therefore, A is true. What about B? In statically typed languages, if the compiler doesn't give you any warnings, that means there's no LSP violations. Well, even going back to our simple example with our square and friends. So up here, this is the Liskov violating version of the example. And imagine that Ruby had static type checking the way that Java has. There's nothing in here that would suggest that there's any errors, right? And if we wanted to do this twice as wide as high thing, we could write the method to raise an exception, and we could declare which exceptions are thrown, and Java would be happy. So the LSP violation is really not something that can be caught syntactically most of the time. There are symptoms of it, and like I said, the most obvious symptom when you're coding is you try to make a change that's in a subclass, and you realize that it's triggering you to make a change in a superclass. That means that the subclass is doing something that you had not anticipated, and maybe isn't a case for inheritance after all. OK, therefore, B is clearly false. And that makes the answer is orange, that only A is true. OK.